we are going to do 8.3. Get everything where I need it to be. All right, we're on 8.3. Okay. The first thing we need to look at is a rule, an algorithm. If you have two things being multiplied that have the same index, like the square root of something and the square root of something, the cube root of something and the cube root of something, you can multiply the two together. For instance, the square root of 2 times the square root of 3 would be with the square root of 2 times 3, which would be the square root of 6. Okay? So if I had the square root of 5 times the square root of 7, I get the square root of 35. If I have the fourth root of 8y times the fourth root of 3r squared, I get the fourth root of 8y times 3r squared, which is the fourth root of 24r squared y. I put the r squared first because it's standard practice to put the letters in the order of the alphabet. Okay? But if you to put yr squared, it would have been the same thing. It's fine. Okay. Same with if I have the nth root of a over b, I can separate it and say it's whatever that root is of a over whatever that root is of b. Okay? So if I have the square root of 16 over 25, I can say that's the square root of 16 over the square root of 25, which is 4/5. Okay? If I have the square root of 7 over 36, I can say that's the square root of 7 over the square root of 36. I don't know what the square root of 7 is, but I know the square root of 36 is 6. Okay? If I had the cubed root of m to the 6th over 125, that would be the cubed root of m to the 6th over the cubed root of 125. And remember, divide this into this, and I get m squared, and the cubed root of 125 is 5. Okay? All right. Then what do I do if I have the square root of 24? The square root of 24 cannot be, it's a perfect square. So it's not like it's almost 5. If it was 25, it would be 5, but it's 24. Well, the same idea that if I multiply two square roots together, I get the number, I can also separate them. So if you think about perfect squares, 25 would be too much. Now go down. That's 5. 4 times 4 is 16. 3 times 3 is 9. 2 times 2 is 4. And 1 times 1 is 1. Do any of these perfect squares divide evenly into 24? Well, 4 does. I can say it's 4 times 6, which means I can separate it and say it's the square root of 4 times the square root of 6. And what is the square root of 4? 2 with the square root of 6 left over. Okay, stop and look at what I just did and think about that. So if I had the square root of 200, well, you got to go 12 times 12 is 144. 11 times 11 is 121. 10 times 10 is 100. You got to find the largest one that goes into it. So I could actually say that's 100 times 2, which is the square root of 100 times the square root of 2, which is 10 square root of 2. You have to find the biggest one. I could have said, could I have not have said, that's 25 times 8, which means the square root of 25 times the square root of 8, which is 5 square root of 8. But looking at 8, you have to realize that 8 can be 4 times 2, which means it's 5 times the square root of 4 times the square root of 2, which is 5 times 2 times the square root of 2, which gives us what we came up with in the first place. if you don't find the largest one, you have to keep going. So it's the easiest to do is to find the largest one. Okay? Hang on. Get a new whiteboard here. All right. So what if I had the square root of 16 and cubed? Well, let's look at the, first of all, 16. That is a perfect square. But we're going to look at it. We're going to separate the numbers and the letters. All right. The square root of 16 is 4. So I don't have to, that's it, that's reduced. But now this is a 2 here. 2 goes into 3 once with 1 left over. What did I just do? Let's look at just what if I had the cubed root of x to the 5th, y to the 9th. Okay. 3 goes into 5 once with 2 left over. And 3 goes into 9 3 times. There's your answer, simplified, if it's just variables. Right? Let's look at one with variables and numbers. What if I had -8, x to the 4th, y to the 5th? Okay, separated. I have this, and I have this. The cubed root of -8 is -2. But here, what can I simplify? 3 goes into 4 once with 1 left over. 3 goes into 5 once with 2 left over. So my answer would be -2xy times the cubed root of xy squared. All right, let's do a couple more. What if I had the square root of 200 k to the 7th q to the 8th? All right, that's the square root of 200 times the square root of k to the 7th q to the 8th. Okay, let's do 200. 200 is the square root of 100 times the square root of 2, which is 10 square root of 2. Okay. This one is 2 goes into 7 3 times with 1 left over, and 2 goes into 8 4 times with none left over. So this, it comes down, and now we just have to multiply outsides with outsides, insides with insides. So I have a 10, I have a k cubed, and I have a q to the 4th, and on the inside I have a 2 and a k. You multiply outsides with outsides, insides with insides. Okay? Let's try one more. What if I had the opposite of, or negative 4th root of 32 y to the 9th? Okay? That means it's negative 4th root of 32 times 4th root of y to the 9th. 32 is not a perfect 4th root. Okay? 32, think about perfect fourths. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. And 3 times 3 times 3 times 3 is 81. Does 16 divide evenly into that? Yes, it does. So I have the opposite, okay, the 4th root of 16 times 2, which means the 4th root of 16 times the 4th root of 2. This makes this 4th root of 16, which is 2, -2, with the 4th root of 2 left over. Now let's worry about this. 4 goes into 9 how many times? Twice, with 1 left over. So now, outsides with outsides, -2y squared, insides with insides, 2y. That's your answer. Okay. On a more simple note, the cubed root of 16, how can we reduce that? Think about it. 1 times 1 times 1 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. Will that divide into that evenly? Yes, it will. So I can rewrite it as 8 times 2, which means it's the cube root of 8 times the cube root of 2. The cube root of 8 is 2, and you have that left over. Okay? All right. The last thing in this section, the last thing in 8.3 deals with that's awful. Wait a minute, let me try that again. The Pythagorean theorem, which deals with a 90-degree triangle, or a right triangle, a triangle that has a 90-degree angle. Okay? Now, you have the two sides, A and B, and you have the hypotenuse, which is B. And the Pythagorean theorem says A squared plus B squared has to equal C squared. Okay? So if I told you that A was equal to 4 and B was equal to 6, and I wanted you to find C squared, then I would put for A and for B, I would put 4 and 6. Okay? So you have 4 squared, which is 16, plus 6 squared, which is 36, that's equals C squared. So that's 52 equals C squared. Now, in order to solve for C squared, we take the square root of both sides because it's a perfect square. So if you take the square root of C squared, you get C. But we have to also take the root of 52. And that's not a perfect square root. So how can we reduce it? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 16, 25, 36, 49, 64. All right. Looking here in this way, what perfect square goes into 52 evenly? Well, 4 goes into it. 4 is the only one. 4 is the largest one. Because 52 can be written as 4 times 13, which means you have the square root of 4 times the square root of 13, which means you have 2 square root of 13. So they're going to have you do this to help you to reinforce the simplifying of radicals. Okay, that's 8.3. All right, let's go to 8.4. 8.4 actually requires everything that you know from 8.3. Okay. Oh, wait a minute. Back. I have to go back to this room still. There's one more thing that they throw in 8.3, and that's the distance formula. It's the distance between 2 points on a graph where you have your y and your x-axis, so a point's going to have an x number and a y number. Okay? The distance between 2 points on the Cartesian plane is equal to x2 minus x1 squared plus y2 minus y1 squared, and then the square root of all that. So if I said I have points 3 and negative 5 and 6 and 4, okay, what is the distance between 3, negative 5, and positive 6, 4? Well, we fill it in. Now, first of all, let's give them their little, is this the x and this is a y, this is an x and this is a y. And it doesn't matter. I'll make these my first ones and these my second ones. It doesn't matter. Distance is equal to, what do I put in for x2? 6. What do I put in for x1? 3 squared plus, what do I put in for y2? 4 minus, what do I put in for y1? Negative 5 squared. Oops, squared. So distance is equal to, what is 6 minus 3? 3 squared plus, now Remember, when you have two negatives like that, we have to add the opposite. So we get 4 plus 5, which is 9. Plus 9 squared. So distance is equal to 3 squared, 9, plus 9 squared, 81. So the distance is equal to the square root of 90. Now, the only thing we have to now determine is there a perfect square that divides evenly into that? I don't think so. 16. 16 times 5 is 80. 36. No. Nope. So that's as far as you can go. Square root of 90. You can't reduce it at all. Okay? All right. Now on to 8.4. 8.4 is taking everything that we have learned so far and putting it together. Now, if I had 4 times the square root of 2 plus 3 times the square root of 2, I need you to see that these are like terms. What comes after the number is exactly the same. So because of that, they're like terms, so we can add the numbers together. It's kind of like 4x plus 3x equals 7x, and instead of x, it's the square root of 2. Outsides with outsides, insides stay the same. Okay? So with that said, what if I had 3 times the square root of 24 plus the square root of 54? As it stands right there, can you add those together? No. But can we change the look by simplifying the root? Meaning, 24 perfect square is 4 times 6. So that's 3 times the square root of 4 times the square root of 6, which is 3 times 2 times the square root of 6, which is 6 square root of 6. So this becomes this. Now, we're about 54. The perfect square that resides in 54 is 9. So that can be 9 times 6, which means the square root of 9 times the square root of 6, which means 3 square root of 6. So we'll just bring that down. Now are they the same? Yes, they are. 6 radical 6 plus 3 radical 6 equals 9 radical 6. Okay, so we're going to be adding and subtracting. What if I had 2 times the cubed root of 16 minus 5 times the cubed root of 54? Okay, now we have to think perfect cubes. 2 times 2 times 2 is 8. 8 will go into 16. So I can rewrite this as 8 times 2, which means I can separate it, which means this comes out and becomes 2. So on the outside, I have 4 cubed root of 2. Okay, 54. 3 times 3 times 3 is 27. So 54 can be 27 times 2, because 27 is a perfect cube. So that means I can write it as 5 times 3 times the cube root of 27 times the cube root of 2. So that's 5 times, what is the cube root of 27? 3 times cube root of 2, so I have 15 cube root of 2. Now I have 4 cube root of 2 minus 15 cube root of 2, which gives me negative 11 cube root of 2. Okay? All right. What if I had, let's try a couple more. 2 times the square root of 20x minus the square root of 45x. Okay. What perfect square is hiding inside of 20? 4. So I can rewrite it as 4 times 5 times x, which means it's 2 times the square root of 4 times the square root of 5x. And the square root of 4 is 2 times the square root of 5x, so I get 4 times the square root of 5x. Minus, what perfect square is hiding inside of 45x? Or 45, because x is just x, there's not enough. In other words, 2 into 1, which is that exponent. There's not enough. So this would be 9 is the square root that's hiding inside of it. So I can rewrite it as the square root of 9 times the square root of 5x. And the square root of 9 is 3 times the square root of 5x. So I get 3 square root of 5x. So 4 square root of 5x minus 3 square root of 5x is 1 square root of 5x. And you can either write the 1 or leave it out. You don't have to have it there, because we know if it's not there, it's assumed. All right, last one. The cubed root of p to the 4th q to the 7th minus the cubed root of 64 pq. All right. For letters, remember we divide. 3 into 4 goes once with 1 left over. 3 into 7 goes twice with 1 left over. Minus. Not enough in these, so those stay. But what about 64? What perfect cube is 64? 64 is actually a perfect cube. It is 4 times 4 times 4. So we can separate it this way. So this becomes 4 times the cube root of PQ. And then this is PQ squared times the cube root of PQ. Now, this is the same, but can you subtract 4 from PQ squared? No. So that is as far as you go. All right. We're good.